Okay, today's video is going to be a kind of short one because the goal of the day is going to be for you to write the code for insertion sort. So hopefully you already have this worksheet, and it's just kind of an outline. I didn't really put much on there, but there is an overall running method, public something insertion sort, similar to selection sort. This should be a pretty quick method to write because it's almost identical to selection sort that I did give you. Find position for insertion sort, remember, it's got to return the position of the value or of the index of the value where the current spot should be going to. So if it's returning a position, think about what type of method it would be. And I'll review what insertion sort did again real quick so you can think about the code for this. But it's basically starting from the current position, going backwards, looking for someone smaller. If it finds someone smaller, it's found where it needs to go. If it gets all the way through to the start of the array, we have to return position 0. And then if you flip it over on the back, there's a shift method. And shift is supposed to just move elements around. So think about what type of method that would need to be again. And think about what information you would need to know. You'd have to go from the current spot down to where it's moving, shifting everything as you go. Okay? So a couple things to show you quick. First off, here's another representation of selection sort. So selection sort you've already got the code for, but if I hit go here, it's going to start running. And remember what selection sort does is it's looking for the smallest element in the array. And when it finds something smaller than it, it swaps it with it. So currently 5 is the smallest, so it swaps 5 and 44. It's looking for something smaller than 38, swaps with 38 and 15. Looking for something smaller than 44, swaps. Looking for the smallest, swaps with 47. Looking for the smallest. And that's why you have the code. It has to go through everything, find the lowest, and then swap. By the time you're done, it's sorted. Insertion sort, this is where you might want to look a little bit longer. And I don't want to make it quite this long, so let's take away a few of these here. What's that? Okay. And then here we go. So remember, the first spot is where I'm looking for where 5 goes, shifting until I find where it needs to go. Looking for where 47 goes, it found it. Looking for where 15 goes, shifting and insert. Looking for where 36 goes, shifting and insert. So I'm always looking for the smallest, something smaller than it. When I find it, I shift and insert. Looking for someone smaller, there he is, shift, insert. This one's going to have to look all the way to the beginning before it finds someone smaller. And then once it finds someone smaller, shifts and inserts. Okay, so that's how insertion sort works. Now I told you I would show you a quick visual representation. This isn't the best thing that I could find, but it's a video on YouTube that someone made comparing a bunch of different sorting algorithms. And selection sort is going to be in the upper left corner, insertion sort is going to be in the upper right. The other ones don't really matter, but I want to show you how, depending on how the elements are originally sorted, if it's more efficient to use selection sort or insertion sort, or if it doesn't really matter. So here if it's sorted randomly. Again, there's lots of different sorts that I don't even know all of these. But here's selection sort, here's insertion sort. And you can see selection sorts looking for the smallest element and then swapping with the current spot. So it's kind of slow getting to that spot. But eventually it's going to get there. Sorry, I turned the music off if you loved it. This one, insertion sort, is going a little bit quicker. It's finding where it needs to go and insert. Obviously there's other ones that are quicker, but it still has to look through quite a few elements to find where to go. See, their selection sort is still going. It's a little quicker at the end because there's fewer things to look for, but still making comparisons and doing that. All right, I'm going to jump ahead to it's sorted in reversed order. So I want it sorted the other way. So selection sort has to find the smallest and swap with it It doesn't find the smallest till it gets to the end, but it's got to check everything anyways. So this is really no slower this time than when it was sorted randomly. Insertion sort, this is its worst case scenario. Because every time it's got to look for someone smaller, it's going to have to go all the way to the beginning of the array before it finds someone smaller. So I don't know which one's going to end up being the quickest one this time. I would think a selection and insertion sort would be pretty similar because it's got to search and shift. So in worst case scenario, I would expect these to be almost identical. It's looking like that way. Selection may even beat it. It did. So it might take a little bit longer to search. Insertion's still going. So worst case scenario, insertion sort is worse than selection sort, in this case at least. And the last one you're going to see in a second here is if it's best case scenario, if it's already sorted. Remember what I showed you yesterday, insertion sort, if it's already sorted, it doesn't need to shift and only needs to make one comparison every time. So insertion sort should be super quick. Let's get over there. There's already sorted, or almost sorted. So look, insertion sort's done already. If you're already sorted, insertion sort is probably the best sorting algorithm. Selections, even though it's already sorted, in order for it to know that it's already sorted, it's got to go through everything until it shifts it. So selection sort's going to take a while again. Okay, so I don't know if that helps or not, but that's just a quick visual representation of big O notation, how it does matter depending on what scenario you're at, but overall in random case scenarios, selection and insertion kind of take the same amount of time. All right, so that's all I got for the video today. Again, the main thing I want you to do is to write this code for insertion sort. If you need help, you can come talk to me, but I would say get your selection sort notes out, because you should at least be able to write kind of the insertion sort driver method here. Just use selection sort, but instead of find lowest and swap, you're going to be doing find position and shift. But that should give you a hint on what needs to be sent over to these other methods. Remember, find position, again, you're looking for someone smaller. So you're starting from the current spot, going backwards to the start of the array, and every time you're checking, is the current element smaller than the one I'm looking at? If it is, we're going to return the spot that needs to go in. If it's not, I'm not going to do anything. I'm just going to keep going. And if I get all the way through that search and never find something smaller, I got to return the beginning of the array. And then what shift needs to know is it needs to know where you're currently at, where you're shifting to. And it's got to go from the current spot to the spot we're shifting to. And at each spot, I want to set current spot equal to 1 before it. So think about how I would say in general, set the current element equal to the one before it. And also don't forget, you've got to save the spot you're currently at before you start shifting into it. Because at the end, the spot that you're inserting into needs to be that saved element. All right, so hopefully that gives you at least a starting spot. When you finish or if you get stuck, come show me what you've written so far, and I will check it over for you, because you'll need this to be a good copy for your next program that you'll start tomorrow. Good luck.